Okay, we looked at the law of sines. Now we're going to look at the law of cosines. So our law of cosines is a little bit more complicated as far as what the equation is. Okay. So here we have, notice this looks very similar to our Pythagorean theorem with some extra stuff added on, or in this case subtracted. So notice here, if we have A, then we have B and C here, C, A and B, B, A and C. So you have all three letters represented. Okay? So whatever letter this is, the other two letters are here. Then notice that these two letters match these two, and that's true of all of these. So we have BC here, that's a BC. We have AB here, so that's an AB here. We have an AC here, so that's an AC here. Okay? And then notice that there's a correlation with these letters. Right? So if this is B over here, then this is angle B. Remember, this represents side. This is side A, angle A, side C, angle C. Okay? So that's how I help myself remember the formula. So you've got A squared, and then your other two letters, minus double the same two letters here, and then cosine, and then this letter, that's the angle of that letter. Okay? Now, if we look again at our proof of how this works, so we're given our triangle, which is this triangle here, and we can create an altitude just like we did yesterday so that we start with a right triangle, because our sine, cosine, and tangent that we know currently is that it has to use a right triangle. So we create an altitude, and then we can take the sine of C. So if I label this triangle, this is opposite, this is adjacent, this is hypotenuse. Okay? So our sine of C would be opposite over hypotenuse, which is h over a. The cosine of C would be adjacent over hypotenuse, which in this case is x over a. So on both of these, we're using angle C, and this is our trig ratios definition. Okay. So if we look, what happened from this line to this line? Well, here we had fractions. Here we don't have fractions. So here I multiplied by a on this side. Here I multiplied by a on this side. So I can do that on both of these because of the multiplication property of equality. Okay. So then if I look here, b equals x plus y. So I'm going to go back to my picture. This b, that's this side right here, equals x plus y. Now we have a name for this that you may or may not remember depending on your recollection skills. This is the segment addition postulate, where you do part plus part equals the whole. So this is the segment addition postulate. Remember, postulates are accepted without proof. Theorems you have to prove. Okay. Then this says y equals b minus x. So I'm going to do y equals b minus x. Okay. Well, we just had that b is x plus y, and then I moved this x to the other side. So from here to here, I solved for b, which means that I added x to the other side. So this is the addition property of equality. Okay. So then I have y equals b minus a cosine c. Well, this is the same except for this part here. So I'm going to go, okay, well, what did I know from before? Well, I look up back here, and I can see that our x value is really a cosine c. So I plugged in place of the x, I plugged in a cosine c. So that is the substitution property. Oops. Okay. So then I've got y squared plus h squared equals c squared. Well, I had a y squared, or y here. I could square it, but that doesn't seem to give me this part, so I'm going to go back and look at my picture. So y squared plus h squared equals c squared. Y squared plus h squared equals c squared. Well, this is a right triangle, and that's just our Pythagorean theorem. So this part we know is true because of the Pythagorean theorem. Okay, so then we've got y, which is this whole thing. Well, we just had up here what our y equals, right? So this part here was the same as our y. So in place of y, we plugged in b minus a squared. Well, h, I didn't have, this was not an h, then not an h. Oh, look, here we have an h here. So we've got our h is really a sine c. So I plugged in place of my h the A sine C. Okay? So I substituted in again. So this is our substitution property. Now, I would not anticipate that you would be able to come up with this theory or this proof all by yourself. Okay? I do expect that you'll be able to follow along and see how we're getting from pieces and putting the pieces together. Okay? So then here, we've got this whole thing here. Okay? Well, if we have something squared, that means the thing times itself. So I'm going to come up here and we're going to think, okay, b minus a cosine c times b minus a cosine c. Okay? Well, that's this thing squared. So b times b gives us b squared. B times a cosine c is, well, there's a negative. So negative ab cosine c. And then b times negative a cosine c is negative ab cosine c. It could be ab or ba. Either one gets you to the same spot. And then we've got a cosine c, negative a cosine c times negative a cosine c is positive a squared cosine squared of c. Now, when we do cosine squared, you do the squared before the angle. Okay? So notice here that these are like terms. AB cosine C, AB cosine C. So I really have B squared, which is this one. I have two of these, which is this part right here. And then plus A squared cosine squared C, which is this part. So this entire thing expands to this. If I square this, I have to square both the A and the sine. So A squared sine squared C, right? So this is just simplifying. Or you could call it multiplying because that's what you're doing as well. Okay. So if I look here, this entire thing matches this one. And then suddenly this, we take out the a squared. So notice there's an a squared in both of these, which means that it's a common factor of a squared. So we take out the a squared cosine squared c divided by a squared is just cosine squared c. A squared sine squared c divided by a squared is sine squared c. Okay? So we have cosine squared c plus sine squared c that's left over. So this stayed the same and we factored. Okay. Now, hopefully you remember from last year this piece of information. If you don't remember, we had something called our Pythagorean Identities. And our Pythagorean identity was sine squared plus cosine squared equals 1. Okay? If you don't remember that, we'll be looking at why that's true later. So just know that this is something that you theoretically should know. So sine squared plus cosine squared equals 1. So then this thing here is the same thing as this one. It's a different order, but it's the same thing. So in place of here, I can really put times by 1. I can substitute in 1. Well, 1 times a squared is really just a squared. So notice this stayed exactly the same, and then it was a squared times by the unsaid 1, which is really a squared. So this is our substitution property. Okay. So then we've got this thing here. And then all we did was reorder it. So the A went first, the B went next, and then this thing stayed the same, equals the C squared. So this is our Law of Cosines formula that we have up here. So we'd have to run through and do the same kind of thing if I create an altitude from C and if I create an altitude from A. Okay? And then run a similar proof for all of these with those two other scenarios. And then it would prove all of the law of cosines. Again, I'm not expecting you to be able to replicate this all by yourself. I do think that you should be able to understand the reasonings and how we get from one spot to another. Okay. Now, when you are mixing law of sines and law of cosines, there's a particular order that you have to go in. So I'm going to show you an example, and then we'll come back and look at this part up here. Okay. Now, when you have the law of cosines, notice if we create a triangle for this one, find the angles of a triangle that has side lengths 8, 14, and 19. So notice here that we have 8, 14, 19. I'm just doing something that looks sort of nearish that. It's not to scale for sure, but this is shorter, this is medium, this is long. Okay? So notice here, I have no angles, and I have nothing that can make it so that I can find an angle, unless we use solving law of cosines. So that means I don't have an angle and side across from each other like we need for law of sines. So if you don't have a side and an angle across from each other, you have to use the law of cosines. Okay? So if we find the law of cosines, okay, so notice here we've got side, side, side. These are side, side, side. That's what I'm given. Okay? Use the law of cosines to find the angle opposite the longest side. So I want to find this angle here. So that we have the same thing, let's call this hat. Okay. So I want to find angle A first. Now, if you're going to use the law of cosines to find all of the angles, that's fine. You will get the same answer every time. If you're going to use the law of cosines and then switch and use the law of sines, you have to go in this particular order. Okay? Because of what we're going to learn at a later point in time. So here, if I'm trying to find angle A, that means that I want cosine of A over here, which means this angle matches this letter of this side over here. So this will be A squared. Well, if this is A, this is my other two letters, which are, in this case, H and T. So H squared plus T squared. And then I'm going to do minus double those two letters, so HT, and then the cosine of the angle. So this is how I help myself remember the formula. These two things match. I need all three letters represented here. These letters match these ones here. Okay? So now I'm just going to plug away and figure out what my answer is. So our A squared would be 19 squared equals H squared, which is 8, plus the T squared, which is the 14 squared, minus 2 times 8 times 14 times by the cosine of A. Okay? Now, you have to be very careful with this. Notice here that this cosine is being multiplied by these three things. So you need to solve this in parts. I need this as a part, this as a part, and this is a part. Okay? So if we do 19 squared gives us 361. If I do 8 squared plus 14 squared, that gives us 260. Minus 2 times 8 times 14 gives us minus 224 cosine of A. Okay? I cannot add the 260 and the 224 or subtract them because this negative 224 is being multiplied by the cosine. So instead, I have to do my order of operations backwards. I get rid of the 260 first by subtracting 260. So if we do 361 minus the 260, that gives us 101 equals negative 224 cosine of A. So here, to get the cosine by itself, I need to undo timesing by the negative 224. So to undo timesing, we divide by negative 224. So this just gives me 101 divided by negative 224. Oops, I put 225. Which gives us negative 0.4509 when I round equals cosine of A. Okay. Actually, I'm going to show you on my calculator this. So 101 divided by negative 224. Okay. So that gives us negative 0.4509 when I round. Okay. So here we want to undo the cosine now. Well, to undo the cosine, I'm going to use the inverse cosine. Whatever. This is fine. So the inverse cosine of both sides, remember your inverse cosine goes on the left side. You got to kind of squish it on this one. The inverse cosine of the cosine, those undo each other. So that leaves us with A equals the inverse cosine of negative 0.4509. Now, when I go to my calculator, this is rounded on our paper. If I do this, I will carry a rounding error throughout the rest of my problem. So to avoid a rounding error, I'm going to use second answer. So I'm going to go to my calculator, and I'm going to do second cosine, but instead of typing negative 0.4509, I'm going to do second, and then my answer button is above the negative sign. and it will use that entire answer, so now I'm not carrying a rounding error throughout the problem. So second cosine, second answer, so that gives us 116.8. Okay? Just so you can do, if you do second cosine, negative 0.4509. Okay? So it's okay for a little while, but notice our number starts to vary, right? So this is what I'm talking about, that you would be carrying a rounding error throughout the problem. So 116.8. So that means that angle A is 116.8 degrees. Okay. But we're solving the triangle, which means I need these angles as well. Well, notice I now have an angle and a side across from each other, which means I could use law of sines. I could also use law of cosines, and I could set it up. This is a little bit more tedious of a process than law of sines is. So most people like to intermingle using law of sines and law of cosines. However, you can run into a problem. So this is why we have this. Use the law of sines to find the either remaining two acute angles. Find the third angle by subtracting the measures found in step 1 and 2 from 180. If you have side angle side, you find the side opposite the given angle, and then you go the angle opposite the shorter of the two sides. So the way that I remember is I combine these pieces of information, so I don't have to remember which goes with which. So you either find the side opposite the given angle or the angle opposite the longest side first. And then I just remember this one, that you find the angle opposite the shorter of the two sides next. Okay? So instead of remembering side angle side, it matters which you do next, side, side, side. It doesn't matter which one you do next. I always do the opposite of the shorter side. Okay? So here, I'm going to find h next. Okay? Now, since we have our law of sines that we can do, I can do 8 over sine h. I'm going to move up here. So 8 over sine h equals 19 over sine a. Oh, which we just found a. So 116.8. Okay. So this is what I've set up. So this is our yellow part. This is our green part. Okay. In order to do the law of sines, I have to use something that I just found. Again, we can cross multiply to solve. So that gives us 8 sine 116.8 equals 19 sine h. Well, I don't want 19 sine h, so I'm going to divide by 19. So sine h, now, again, we used 116.8, but if I use just 116.8, I will continue a rounding error. So instead of using 116.8 in my calculator, I'm going to use second answer. So 8 sine second answer, because that's the 116.8 that's sitting in my calculator, and then divided by 19. And that gives us 0.3, I should make sure, don't forget to make sure that you're in degrees. So 0.375. So sine h equals 0.375. Now again, well, I guess I don't want to say that yet. So here we want to undo the sign. To undo the sign, we're going to take the inverse sign. So the inverse sign of the sign, those undo each other, so we're left with h equals the inverse sign of this. Again, I rounded this, but if I put the rounded answer in my calculator, I will continue to carry a rounding answer. So instead of doing the rounding number, I'm going to do second answer. So I'm going to do second sine, second answer, and then that gives me 22.075. So then h is 22.075. Okay. So now I have 2 of my 3 angles, right? So if I've got 2 of my 3 angles, I can find my third angle. So over here, angle T is just going to be 180 minus the other 2 angles. So minus the 22.075 minus the 116.8. Okay. So I'm going to do 180 minus second answer because that's sitting in my calculator. And then I'm going to look back above. So notice above I can still see the 116 answer. I'm going to use the one that's not the rounding error, so the one that the first 116 answer. So minus 116 point, and then I'm going to go out several decimals so that I don't get as much of a rounding error. So 0, 0, oh, there's only 2 zeros. 0, 0, 9, 8, 3, 1. There we go. So that gives us 41.124. So then our last one, angle T, is 41.124, assuming I remembered right. Okay. So that gives us our angle of the last one. Okay. So now we have all three of those angles, and I've solved the triangle. Okay. Now, if we look at this one, we have our side that we want to find, and then our angles that we want to find here. Okay. Now this one is a side angle side. So this one we would have to follow this one. So we want to find the side across from the given angle. So in this case I want to find A first. Then after I find A, then I would need to find across from the shortest side next. So between 9 and 12, 9's the shortest side, so then angle C. So if I solve this problem, we want to find our A first. Well, that means we have A squared, because that's what I'm looking for. The other two letters that aren't A, so in this case that's B and C. So B squared plus C squared minus 2 times those same letters, so BC, cosine of, and then this angle matches, or this letter matches this letter, so A. So now we can plug and chug. So then this gives us A squared, which is what we're looking for. B squared is 12, or 12 squared. C is 9, so plus 9 squared minus 2 times 12 times 9 times by the cosine of A, which is 25. Now on this one, we have the entire thing on this side, so there's no variable to solve for on this side. So then I can just put that whole thing in my calculator. So we can do 12 squared plus 9 squared minus 2 times 12 times 9 times by the cosine of the angle, which is 25. So that gives us 29.24 equals A squared. Well, here we don't want A squared, we want A. So this is a common error that you'll find this answer and then forget to take the square root. Because we're talking about distances and our distances aren't negative, then you need to take the square root. So I'm going to do second square root, second answer. Again, I'm using answer so I don't get a rounding error. So 5.407. So A is 5.407. Okay. Then we need to find these two angles, but I have to find the angle across from the shortest side next if I'm going to switch to law of sines. You can do the law of cosines, but you'll be solving for an angle. When you're solving for an angle on law of cosines, it's a little bit more tedious than just solving for a side. This is why people like to switch to law of sines. So we can switch to law of sines because now we have this side and angle across from each other and this side and angle that we want to know. So we can set it up so we do 5.407 over sine 25 equals 9 over sine C. So I'm going to cross multiply. So 5.407 sine C equals, is that a 9? Yes, oh. I was determining if that was a 9 or an A, but it's a 9. Equals 9 sine 25. Okay. So here, I want the sine C by itself, so we're going to divide by 5.407. So sine C is 9 sine 25, oops, divided by sine of second answer. Oh, I forgot that I was using this calculator. 9 sine 25, close your parenthesis, divided by sine of second answer. No, it's not sine of second answer, just second answer. Divided by second answer. Oh, seriously. 9 sine 25, close your parenthesis, divided by second answer. Goodness gracious. 9 sine 25. So that gives us .703. So sine 3 is 0.703. Well, I don't want sine c, I just want c. So to get rid of the sine, we're going to undo the sine. Well, to undo the sine, we're going to get second sine, second answer. So we go to the calculator, second sine, second answer. So that gives us 44.703. So our c is 44.703. Okay. Usually in my diagrams, I abbreviate or just truncate the angle at the first decimal because it gets really squishy here. So then to find angle B, we have 2 of 3 angles, so I can just use the fact that there's 180 degrees in a triangle, so I can do 180 minus the 25 minus the 44.703 to get to angle B. So we can do 180 minus second answer, because that's our 44, and then minus the 25 that we were given, which is 110.297. Oops, 0.297. So then we have all of our missing sides and angles. Now you can do a quick check. This is the biggest angle, that's my longest side. This is my smallest angle, that's my shortest side. This is medium and medium. So you can do a quick check and make sure that you didn't royally mess up anything here. Okay. Again, if you're going to do the law of cosines on each one, then you don't need to worry about this part. If you're going to intermix them, you need to remember either find the side across from the angle across from the longest side, or the side across from the given angle first, then do across from the shortest side next. And then that will always give you the correct answer. Again, we'll get to why you need to do that, but we're not there yet.